Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0118 indicates an issue with the engine coolant temperature, ECT, sensor 1 circuit showing high voltage. The ECT sensor is vital for measuring coolant temperature, influencing several engine management systems, including fuel injection and ignition timing. In terms of location, ECT sensor 1 is typically situated near the engine block, attached directly to the cooling system for accurate readings. When the ECT sensor provides erroneous data, such as exhibiting a temperature of about -40 degrees Celsius, indicating a fault, the engine control module, ECM, may behave unexpectedly. Generally, the vehicle's performance can be compromised, leading to reduced efficiency or even stalling under certain conditions. The problem requires thorough exploration to verify the fault before any extensive repairs are initiated. The ECT sensor 1 plays a crucial role in monitoring the engine's coolant temperature, which is essential for maintaining optimal engine performance. It helps the engine control module, ECM, make informed decisions regarding fuel injection and ignition timing based on the coolant's temperature. This sensor is usually found near the engine block, where it is well connected to the cooling system. Its location is critical as it ensures that the readings are accurate and timely. If the sensor fails, it may report extreme values such as -40 degrees Celsius or greater than 4.92 volts, leading to poor engine performance and efficiency. Hence, understanding its function and location is paramount when troubleshooting. Several potential causes can lead to the DTC P0118 error code. A common issue is a faulty ECT sensor 1, which may fail due to wear or manufacturing defects, resulting in abnormal voltage readings. Furthermore, poor electrical connections, including corroded terminals or loose wiring, can create intermittent signals misunderstood by the ECM. An open or short circuit in the wiring harness can significantly affect voltage levels, leading the system to misinterpret the coolant temperature. Similarly, an underperforming or defective ECM can inaccurately analyze signals from the ECT sensor, prompting erroneous readings. Each of these factors requires individual verification as a part of the troubleshooting process. When the DTC P0118 is triggered, various symptoms may emerge, indicating an underlying problem. One of the most noticeable effects is poor engine performance, which can manifest as sluggish acceleration or unresponsive throttle. Additionally, drivers may notice unusually high fuel consumption as the ECM struggles to optimize fuel delivery based on faulty readings. An overheating engine may also signal issues with the ECT sensor, as inaccurate temperature readings prevent proper cooling system activation. Finally, potential stalling can occur if the ECU miscalculates necessary fuel parameters. Hence, vigilance regarding these symptoms is essential for timely intervention. The first troubleshooting step for diagnosing DTC P0118 involves verifying the problem through preliminary checks. Begin by turning the ignition switch to the on position, labeled as 2, to power up the vehicle's electrical systems. Next, utilize the Honda Diagnostics System, HDS, to monitor the ECT sensor 1 readings in the data list for a valid fault report. The sensor should read an abnormally low temperature of approximately -40 degrees Celsius or return a voltage of 4.92 V or above. If these extreme readings are observed, the failure is confirmed, leading you to the next step. On the contrary, if normal values are present, it is likely that an intermittent failure is at play, warranting a close examination of connections and terminal integrity. In the second troubleshooting step, the focus shifts to examining the ECT sensor 1 directly Start by turning the ignition switch to the lock position, denoted as 0, ensuring all vehicle systems are powered down. Next, disconnect the ECT Sensor 1 2P connector to isolate the sensor from the circuit for further testing. Use a jumper wire to connect terminals A and B on the 2P connector, where terminal A corresponds to the gray wire and terminal B to the pink wire. This setup allows you to simulate normal sensor operation. Then, reactivate the ignition switch back to the on position to observe data again through the HDS. If the readings remain indicating extreme values as before, this suggests the problem continues, pushing you toward the next troubleshooting step. The third step in the troubleshooting process requires evaluating the voltage in the circuit without the ECT sensor connected. Begin by turning the ignition switch back to the lock position before removing the jumper wire, ensuring the circuit is clean for measurement. Repower the vehicle by turning the ignition switch to the on setting again. You will now measure the voltage between specified test points, the connector terminal number 2 from the ECT sensor, and a known body ground should be established. Under these conditions, a reading of approximately 5.0 volts would indicate that the wiring itself is functioning as expected. However, if the voltage deviates from this range, it suggests potential issues in the circuit, which will require you to delve deeper into subsequent checks. Proceeding to the fourth troubleshooting step involves ensuring proper continuity within the SG2 line, a crucial element connecting the ECT sensor to the ECM. Start by turning the ignition switch to the lock position and use the HDS to jump the SCS line, setting the diagnostic system in a test-ready state. Now, disconnect the ECM connector B, which consists of 49 pins. With the ECT sensor connector still disconnected, you will verify continuity between designated test points, the 44th pin of the ECM connector B, and the first pin of the ECT sensor 2P connector. Successful measurements indicating continuity confirm that the SG2 line is not experiencing any breaks or faults. If continuity fails to register, repair efforts must focus on addressing any breaks present in the SG2 wiring. The final troubleshooting step concentrates on examining the continuity of the TW line, another essential circuit in the sensor's operation. Begin the process by again turning the ignition switch to lock. Repeat the procedure of using the HDS to jump the SCS line, and then disconnect the ECM connector B as previously done. With the ECT sensor connector still detached, check for continuity between the 34th pin of the ECM connector B and the second pin of the ECT sensor 2P connector. If continuity is confirmed, then the TW line is functioning correctly, and further troubleshooting may involve ECM updates or replacements. However, if there is no continuity, it indicates a fault in the wiring that needs to be repaired, ensuring the system returns to operational standards. To ensure that all repairs are effective and the DTC P0118 is resolved, the final verification process is crucial. Start by reconnecting all connectors that were previously detached during troubleshooting to restore the system to its original state. After that, reset the ECM using the HDS, allowing the updated software and parameters to take effect. Once this is complete, turn the ignition switch back to the on position and check for any pending or confirmed DTCs once again. If DTC P0118 reappears, it may signify ongoing issues, possibly due to poor connections at the ECT sensor or ECM. If the code does not return, the troubleshooting process can be considered complete, with the vehicle ready for normal operation. Preventive maintenance plays a vital role in avoiding future occurrences of issues related to DTC P0118. Regular inspections of the ECT sensor can help catch potential problems before they escalate into a fault. Alongside physical checks of the sensors, examining electrical connections for integrity and corrosion should be a routine part of vehicle upkeep. Additionally, ensure that the vehicle's ECM software is kept up to date, as software improvements can address previously known glitches or inefficiencies in the system. This proactive approach helps maintain optimal engine performance, ultimately extending the vehicle's lifespan and ensuring efficient operation. In summary, understanding the role of the engine coolant temperature sensor is crucial for effective troubleshooting of DTC P0118. Verifying connections, particularly looking for signs of wear or damage, can often pinpoint the source of the problem. Successful diagnosis relies not only on hardware checks, but also on ensuring that the ECM software is current and well-suited for the vehicle's needs. With careful adherence to the outlined troubleshooting steps, technicians can systematically identify and rectify issues effectively. Additionally, ongoing preventive maintenance practices will help mitigate the risk of similar DTC errors arising in the future, keeping the Honda Civic running efficiently and reliably. Please like and subscribe to the channel. See you next time!